it. One chocolate, one mint, and one caramel. The chocolate box 50, and mine's 40, and the others 25. So if I say the chocolates this, and mine is this, and the caramels is this, let's say, how many amounts, I don't know. Let's say X amount, let's say Y amount, and let's say Z amount. I mean X boxes, Y boxes, Z boxes. And the question says that each box of the chocolate has, let's check it, 50 chocolates. So it will be 50x I will have. I mean, if there are 2 boxes, I will have 100 chocolates. If there are 3 boxes, I will have 150 chocolates. And then the second one, mine says 40. It means that 40 times Y. And then Z has 25. So I will have 25 times Z caramels in total. This is depending on directly how many boxes I have. If I have 2 boxes, I will have 2 times 25, which will be 50 caramels in total. Now here the key point, Cayley made no incomplete trace bags. So when we prepare a box, in this box, we should have chocolate, mint, and a caramel. And when we open the boxes of each of them, there mustn't be remaining chocolates or remaining mints or remaining caramel in that box. So, for example, if I will open 2 boxes of chocolates, I have to use 100 chocolates. If I open 3 boxes of the mints, I have to use 120 mints. So there must be something in my hand. So to do this one, and it says that there were no unused chocolate mints. What is the minimum total number of the boxes? So now we want to equalize them, and we want to find the least common multiple. The least common multiple. So what is the least common multiple of these numbers? When I say 50, 40, and 25, the least common multiple is, I think it is being, tell me, what will be? If I divide by 5, 5 is dividing by all 10, and it is 8 and 5. And later on, I don't have anything else. So this is the least common multiple. So, and then I should get, for example, for the Y, 5 times 40, which will be 200. 5 times 40 will be 200. And how can I get 200s? By using X times something. So what should it be? X to get the 200s. So it should be, I think, 4, right? 4 times 50 will be 200s. And then similarly, how could it be 25, 200s? Which number I have to use? I think 25, 50, 100, so for it will be 8. So 8 times 25 will be 200. So 200 is our least common multiple. And then how many boxes? From the X, I need 4 boxes. From the Y, I need 5 boxes. From the Z, I need 8 boxes. So 4 plus 5, 9, and 9 plus 8, it will be 17 boxes I need, which is part B. Is this okay now? Okay, so we talk about this question, we solve it. If when we say that T is the normal time, we said that 40 kilometers arrive 1 hour late. So 40 times normal time plus 1 hour late. This distance is equal to 60 kilometers times 1 hour early. If T is the normal time, 1 hour early will be this. And then when we calculate then, 40 plus 4 is equal to 60 minus 6. So 10 will be equal to 2T, and T is equal to 5. At the beginning, how did we take? We said that T is the normal time. So the question is asking here, where is it? At what constant speed should he arrive just in time, in the normal time. So let us find the distance first of all. So 40 times t, which is 5 plus 1, 6, which is 240, is the distance. So by using 240 kilometer distance, by using normal time, which is 5, what should it be speed? Speed should be 240 divided by 5, which will be 4, 5, 20, 40, and 5, 80. So 48 kilometer per hour. Where is it? It is part D. Okay? Yeah. And then this is, we explain, if you remember 1, 2, 3, blah, 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 10. So if it is 10, empty or wrong, 9, empty or wrong. So we already did. You can check the video I just sent yesterday link. Yeah, let's have a look about this question. This question, it's talking about the divisibility. So it says that the number is divisible by 10. Just one simple question. When I tell you 75, is this divisible by 10? Answer is yes, no.
No, sir.
No. The number is 80, divisible by 10?
Yes.
So divisibility means by 10, the last digit must be
0.
Number 0. So 3 to the power of m is one number. 7 to the power of n is another number. So when we add two numbers like 25 and 37, for example, I am saying. So is this number is divisible or not? What should I do? First of all, I have to add them. So when I add them, which one is the main part? I mean, which one is in charge? The units digit, which is the last digit, is important for me. 5 plus 7 is 12. So 2, 3, 5, 6. So I am not dealing with this. Divisibility, just look at the last digits or the units digits. So what I mean this one. If I find the number or numbers, and when I check the sums, so what is important for me? Their sum of the last digit is 0 or not. If the last digit is 0, the number is divisible. The sum is divisible. Let me explain here now one empty page. So by looking at the question, by the way, 1 minute. So I am writing m is between 1 and 100. So 1 is less than or equal to m, less than or equal to 100. And then it says that n is 101 and 205. So n is 101 and 205. And here, these are integer numbers. It is important. 3 to m, 7 to n, right? Let me check it. Yeah, 3 to m, 7 to n. 3 to the power of m, 7 to the power of n, divisible by 10. How many pairs we have? How many pairs? Like n, comma n, we have. This is the question. To solve this question, what are we going to do? We will do this, dear ladies and gentlemen, if we have here right now. What are we going to do? First of all, let us analyze our case. So we have 3 to m plus 7 to n. First of all, what is 3 to the power of m? Let's start together. What is the first member of this? Since m is 1, 3 to the power of 1 is 3. The second question?
No, sir.
M is 2, 3 to the power of 2 is 9. This is just one digit number, direct, I am copying. Now be careful. When n is 3, it will be 3 times 9. Always we are multiplying by previous number, right? 3 times 9, which is 27. Let me copy here. So 3 to the power of 3 is 9 times 3. 9 is here. 9 times 3, 27. What is important for me? Last digit is important for the divisibility. So I'm just copying here, pasting here, just number 7. Okay? And 3 to the power of 4. Be careful now. What is 3 to the power of 4? It is 7 times 3. Be careful. 27, of course, you can say, but since I am dealing for the only last digit, 27 times 3 is 3, 7, 21, 3 to 81. But I'm not dealing with this number. The last digit is important for me. For that reason, I am just saying practically in my mind, 7 times 3 is 21. So last digit is 1. Any question till here?
No, sir. Thank you.
And then, thank you. And then the other. Be careful now, the other. So 3 to the power of 5. What will be 3 to the power of 5? 3 to the power of 4 times 3. So whenever I have 3 to the power of 4, the last digit is 1. So 1 times 3 will be 3. And then 3 to the power of 6, this one times 3, it will be 9. So what I see, if I continue, you see now I start with 3, 9, 7, 1, and then 3, 9. When I continue, you will say that, let's continue. 3 times 9, 27, which is 7. I am here. And then one more, which is 3 to the power of 8. It will be 3 times 7, 21, which is 1. So what I see a pattern. I see a cycle. Something is repeating itself. So for every 4 terms, the 5th one, its direct is equal to first one. So the 6th one is equal to second one. This is called module. Have you studied the module? You heard about this? Module 4.
No,
Forget
sir.
about it, not important. If you understand from this concept, 3971, 3971, when I continue, it will be 3971 always. Till here, do you have a question? So I can say that after each 4 consecutive terms, it repeats the pattern. 3, 9, 7, 1. Am I right? Till here, do you have any question?
No, sir. Thank you.
Okay, very good. Now, the second thing, let me analyze, where is it? 7. 7 to the power of n. Same logic. For the 7 to the power of n, what is then 101? So, how can I say? So, let's think like this. If I have 7 to the power of 1, if I have, be careful now. 7 to the power of 1 is 7. Am I right?
Yeah.
7 to the power of 2. It's 49. Since I am dealing units digit, last digit, it is 9. And 7 to the power of 3 is 7 to the power of 2 times 7, which is 7 times 49. But I am not going to do all. I will just check the last digit, which is 7 times 9, 63. So it will be 3. Am I clear?
Yes.
And then 7 to the power of 4, 7 to the power of 3 times 7. So the last digit for the 7 to 3 is 3. So for the 7 to 4 will be 3 times 7. What is 3 times 7? 21.
21.
So 21, last digit is 1. And let me continue. 7 to the power of 5. It will be 7 to 4 times 7. 7 to 4 is 1. 1 times 7, it will be 7. Bingo. I just came here. Let me continue to be sure. Then I will have 7 to the power of 6. 7 to 5 times 7. So 7 times 7, 49. So last digit is 9. And then the other is 7 times 9, 63. Last digit is 3. You see that after this, it repeats itself. So after each 4 consecutive, you know consecutive means?
Yes,
Yeah.
they come one after another.
Consecutive terms, it repeats the pattern 7, 9, 3, 1. Do you have till here any question?
No, sir. Thank you.
Good. Now, our question is this. 3 to n plus 7 to n must be divisible by 10. We are looking for these things. So to construct this one, let's be careful. How can I get some of this 1 star, let me call 2 stars. So since 3 to n always these numbers, since 7 to n always these numbers, how can I pair them? How can I get ordered pairs like m comma n such that their sum will be 0. Let me start like this. If I choose number 3, be careful now. If I choose number 3 for m, what should it be my second number from this? It should be 7, right? This is the case 1. This is the case 1. And then case 2, how could it be? Case 2. Let's do it together. So if I use 3, is there any number here? 3 plus 7, 10. 3 plus 9, 12. 3 plus 3, 9. 3 plus 1, 4. So this is finished. 9 and 7, it's not 10. 9 and 9, no. 9 and 3, no. 9 and 1. So I can say that 9 plus 1. And then case 3, or alternative 3, whatever you call, 7, 7, no. 7, 9, no. 7, 3, yes. 7 and 3. And case 4,
1 and 9.
1 and 9. So do I have any other case?
No, I don't.
Let's think. So if n is 7, m must be 3. But I already said this. N is 7, m is 3. So all the cases finished. Till here, do you have any question?
No,
Yeah.
sir.
Right now, dear ladies, here I am going to use this information. How many m I have? How many numbers are there from 1 to 100? Can you tell me? Is this 100 minus 1 plus 1, which is there are 100 numbers. For example, from 1, 2, 3, how many numbers are there? 3 numbers. 3 minus 1 plus 1. So this is the rule. Okay. Now, here be careful. Here be careful. Each fourth term repeats itself. So if I have 100 numbers, how many times it repeats itself? Can I find by dividing 4, which is 25? Can I say this? What do you think?
Yeah.
So the pattern, which is 3971, repeats itself 25 times. So, hence, for that reason, how many number 3 I have then in this pattern? In the first one, and this is the first 3. In the second, in the third, in the fourth, so in the 25th, I will have, hence, I have 25, let's say, 3. Is this okay?
Yeah.
Okay, now I am looking for how many 7s I have, since my aim is the first 3 plus first 7. First 3 plus second 7. First 3 plus third 7. So how many 7s I have? To find this, I will check this. 205 minus 101. So let me change the color. 205 minus 101 plus 1 is equal to 105 numbers or terms I have. It means that, be careful now, it means that, be careful, this part is important. Number 7, or the pattern of number 7, repeats itself every 4 terms. First 4, the other. So how many group which has the 4 terms I have there? So 105 divided by 4, it will be 21 group and extra 1 member, extra first member of the group. What does it mean? It means that this. So let me say 793. 7931, this is my first group. 7931, this is my second group. Till here, 7931, which is 21. Now 21 times 4. By the way, I did a mistake, I think, not 20. It is 20,
It's
26,
25.
25 or 26?
26, sir.
26. So 26 groups repeat, and the other one, which is the term 105, since 7931, 7931, always it repeats. So the other one, I mean, which is not group, it's a single, it is also 7. Am I right?
Yeah.
So how many 7s I have? So how many 7s I have? Tell me. Is this 26 plus 1, which is 27 7s I have? Is this correct?
I have a question.
Yes, tell me.
Why did you put extra one member of the group?
Okay, reason is this. Here, n is starting from 101 to 205. It means that how many n I will put it. I mean, 7 to the power of, let me tell you here, 7 to the power of 101, 7 to the power of 102, 7 to the power of 103, up to there, 7 to the power of 205. So I am saying that since first 4, which is, let's say, okay, let's say first 4 by using the 1, 2, 3, 4, 5, 6, 7, 8 till 100. After 100, we are coming the cycling from the beginning. I mean 1 to 4, 5 to 8, 9 to 12, and then 96 to 100. So it repeats, but I am not dealing since my first number starts from 101. So 101th term will be still my first number in the pattern. Is this okay? Since 4, 4, 4, 4, 4, I go till 100. So my starting point, which is 101, it is still 7. So 102nd term is ending with 9, 103rd term is ending with 3, 104th term is ending with 1. And then I will continue till where? Till 204. Why till 204? Since when I divide the 105 terms, which is between 205 and 101, there are 26 groups. So this is the first group, this is second group, this is the 26th group. So 26 groups make 104, but I have 105 terms. So after the 26 terms, since it's a cycle like a rounding, so after 1, it must come out as a, let's say, 205th term is 7. Is it okay?
Yeah, thanks.
Okay. Now I am closing this. So let me clean this. What am I going to say, dear ladies? So by using case 1, which is 3 plus 7, so I will make a pairing, right? I'm to get 10, first 3, first 7, first, second 3, second 7, third 3, third 7, something. So how many I have? So for the 3s, I got 25, right? 25, 3, and 27, 7. So can I have 25 times 27 different cases? What does it mean? Let me explain. This is called in probability multiplication rule. Did you hear about this? What is the multiplication rule?
About
Simply let me tell you. Think like that. This is, let's say, Istanbul. This is Ankara. This is, let's say, Trabzon. Let's say. So you want to go from Istanbul to Trabzon via Ankara. You have to pass the Ankara. And you know that there are 3 different roads. 3 different roads from Istanbul to Ankara. You can use one of them. And from Ankara to Trabzon, just only there are 2 roads. So how many different alternatives you have to go from Istanbul to Trabzon? The answer is 3 times 2, which is 6. Let us prove this. This is the first road. 1, 2. I mean, this one and this one. this one, and this one, second, this one, third, this one, fourth, this one, fifth, this one, sixth. Is this okay?
Yes, sir.
So to get 10, by using 3 plus 7, since there are 20, it was 26, I think, and there were 27, 7. So from this to this, there are 26 ways. From this to this, there are 27. I mean, by the first 3, you can use first 7, second 7, third 7, fourth 7, fifth 7, sixth 7. One of them, you can pair this. These are different things, like a coordinate on the XY coordinate system. This is. These are all different things. So let me close this. Come here. So what am I going to do? Since there are 25, 3, 27, 7, to construct a pair like 3, 7, there are this total of amount alternatives. So first 3 with first 7, first 3 with second 7, first 3 with the third 7, first 3 with the fourth 7. Similarly, 25th 3 with 27th 7. Since we are asking all the alternatives, all the possible things, is it okay till here?
Yes, sir.
Okay, if this is okay, by the way, let me take a screenshot so I can share with you. It will be a little bit small, but F3. Okay, now I will continue. I will use same logic. How is the same logic? Case 1, we already finished. What is case 2 now? 9 and 1. But I think it's finished now. Why it's finished? It's easy now. Let me one new top or new empty document. Okay. So now case 2, 9 plus 1. So how will be done? How will be done? When I look at here, how many 9s I have? I have 25 9s, right?
Yes.
Yes.
And how many 9s, how many 7 I have? So the group is, be careful, 7931, 7931, 7931, 7931. So how many 7 I have?
26.
26, not 20. 21 minute. I am looking for 9, right? Not 7. 7 I finished. I am looking right now 9. Is this a case too?
Yes.
Pardon. I am looking. The first one is 9. Second one is 1. So 9 is 25. 9 is here by using the 3. Can I annotate 1 minute? Yeah, by using the 3 to n, I should get 9. This is my case. So how many 9s I have? 25. So I am writing here 25 9s I have. So how many 1 I have in order to get the 10? So I am looking, the 1 will come out from 7 to n. From 7 to n, how many 1 I have? Last term of the each group. So how many groups I have? 26 groups I have. Extra 1 I have, but extra 1, it's not 1, it is 7. Okay, so there are 26 ones. So what am I going to say? 26 ones. So it will be then 25 times 26 different cases. Is this okay?
Yes, sir.
And case 3, now it is simple. When we understand the first one, it is simple. Case 3. What is the case 3? I'm checking here. It says 7 plus 3. So 7 plus 3. So how many 7s I have? I have 25 7s. How many 3s I have? I am checking here. Where is the 3? 3 is the third term. That means how many groups I have? 26. So I have 26, tell me 3s. So it will be 25 times 26. Okay? And similarly, case 4, which is, I think, last case. Case 4, let's look at, what is the case for? 1 and 9. So 1 plus 9. That means from the first, it is still same, 25 ones I have. But what about how many 9s I have? I am checking here. So 9 is the second term, which means all these groups, how many? 26. The remaining one is 7, which is not 9, so I'm not going to use. So it will be 26. So there will be 26 nines. So the answer is 25 times 26. So let me write the total, final result, final. Sum of the all cases. So the first case was 27 times 26. What was it? 25 times 27. So the first case is 25 times 27 plus this case 25 times 26 plus this case plus 25 times 26, and this is also 25 26 for the case 25 26. That's it. So this is the answer of the question. When we use calculator, we can, let me use my calculator. By the way, I can use 3 times this result, right? These are the same thing.
Yeah.
So 3 times the result. I am taking my calculator. 25 times 27 plus 3 times open parenthesis, or no, it's 25 26 25 26. It is 26 25 26 25. Do we have 20 25? Yeah, this is the answer. Okay,
Okay.
difficult question, not simple.
Yeah.
Okay, but we done it.